22. Okay, cool. I need some air on me. I was freezing literally at half an hour. Oh, I was like, melt. Okay. So let's try to make this easy. So they use the phrase, write a sequence of transformations. The thing you need to know is a sequence can just be one or more transformations. Bless you. So if you can see a way to get there using just one transformation, you do not need to panic. Use that one transformation. If you can fly to the mall rather than having to turn left, right, you fly to the mall, right? So it's that kind of an idea. Okay, now, then there's this thing down here that says Dr. Teddy Roosevelt. Dr. Teddy Roosevelt is a president. True, that. He's also the way that we're going to remember our 4 transformations and how we should kind of analyze our pictures to figure out what transformations we need. So the capital D is for dilation, right? That makes sense. Dilation. The lowercase r is for line reflection. And remember, we look at line reflection by looking at the orientation. So think about, I'm looking at the size, I'm looking at the orientation. Make sense? Then, if I can eliminate both of those, then basically I have translation. So that's Teddy. And then Roosevelt is rotation. So we write down, we put Dr. TR to kind of help us go through the 4 transformations and figure out what ones we must use. And then we get to determine the order by what works for us, which means some people might do one thing and some people might do another, and you're both going to be right. Okay? Okay, so here we go. We're going to use vague descriptions on this one, but so this is a recognition piece. So Dr., and you can write it down anyway. I like to do it just this way. Dr. Teddy Roosevelt, like that. So question 1 says, how would you describe using transformations what was done to move object 1 to 2 and then 2 to 3? We're not going to get too crazy, and I'm going to stop your pads. Because we're just going to focus on this. If I'm going from 1 to 2, did I dilate? No. Did I reflect? So this is how you check for reflection. Did you see how this goes AB and this one goes AB? Are they going in the same direction? Yeah. So no reflection was used. So did it slide? Yes. Yes. So that's what we did. So is translation, and we'll just say it was a translation to the right and up. We're going to go very vague here because there's no units on this grid. Okay? And then it's asking us to describe how we go from 2 to 3. So once again, are they the same size? Yep. Reflection. Well, there could be a diagonal reflection, maybe, but do you see how this is D? Well, do you see how like C? No, that doesn't work, right? Can you guys tell that it's not that way? So then it's not just translation because things are no longer parallel. So what did happen? Rotation. And then we can probably make a little bit of an estimation. If we were to connect to D prime and D double prime, it looks pretty close, right? To being 90 degrees, clockwise, origin. It's kind of like playing the game Clue, right? You know, Colonel Mustard in the library with the lead pipe. right? You have to include all 3 pieces of information. You guys know the game Clue?
Yeah, I love that game.
Okay.
I'm gonna play it one day.
It's fun. It's a good movie too. It's fun.
I've never watched
Yes.
that.
If I said rotation with counterclockwise 270.
That would be 100% correct, as long as you name the origin. Yep. Yep. If you're somebody that always wants to use counterclockwise, go for it. All right. So now explain why the 3 figures are congruent to each other. So at the bottom of your green sheet, it says here. It has blank is a rigid motion which preserves lengths of corresponding sides and the measures of corresponding angles. Remember this phrase that I keep trying to force down your throat? So when we go back to our notes, why these 3 figures are congruent, it's because, I'm going to say ... because translation and rotation, you have to name them, are rigid motions okay, are rigid motions that preserve side length and angle measure. Side, hush. Okay. Okay, meat and potatoes, right? I think we just have 3 examples for the whole day, right? Am I right? Yeah. Yeah, it's just 3. Okay, here we go. So ready? This is kind of what we're going to end up experiencing. The middle guy is missing.
The middle thing.
Do you see this? The middle guy is missing. How did I get all the way from here to there?
I know.
Okay, pause. Everybody needs think time. Dr. Teddy Roosevelt.
I don't want.
Okay. Folks, do we need dilation at all?
No.
No. Cross them out. And then this is where you're probably going to pick between one of the 2 R's, but you always check reflection first. A, B, C, A, B, C. A, B, C, A, B, C. Must I use reflection?
Yes.
Yes. So I need reflection, which means I don't think I'm going to need rotation. Are we turning this thing guy at all?
No.
No. Which means we need translation. Now this is where I like to call it dealer's choice. It's kind of like, what are we going to do? Everybody can choose slightly differently. Somebody might want to flip first and then translate. Somebody might want to translate and then flip. Also, do we want to flip this way? No, we don't want to flip upside. We don't want to flip horizontal. We want to flip vertical. But the person that flips over this, well, they have a little bit more work to do. Right? Can you choose a different line of reflection if you want to? Does that make sense? Some people will see it in fewer moves. Okay. Do you guys want to use the y-axis because it's a little bit easier?
Sure.
Sure. Okay. So let's say it. Let's reflect. Step 1. Reflect. Over. So this is, you are describing a sequence. Your step 1, right? This is your step. Reflect over the y-axis. And you ask yourself, are those directions complete? Sure it is. So now we're going to reflect. We're going to do it. Do it. Where's A going to be? Where's C going to be? Where's B going to be? It's up to you if you want to draw it in. I usually do, but kind of stick light, the light color. Okay. Now I need to translate. I would either be picking the C's or the B's to figure that translation out. If we pick the C's, we can do this, right? So what's going to be our translation instruction? Yep. Translate. So you have to say it. Translate. 3 left, and 3 up. That is a complete description. Now, somebody could have translated up and to the right first and then reflected. Do you see? Somebody could have reflected over, is it 2? No. I've had people reflect over the line x equals -1.5 before, so they only have to move the triangle up. People do crazy things. We all see things differently, okay? Ready to turn the page?
Yes, we are.
Turn the page. Beep. We're going to be done in 5 minutes. Yes. Okay. All right, here we go. This is a multiple choice question from the Regents exam. This is very much like questions you would have on your quiz, okay? So it's multiple choice, and typically it's which one will work. Triangle ABC and DEF are graphed on the set of axes below. So something that's helpful is doing this. ABC, I don't know why I did that, DEF, right? So we know who corresponds with who. Remember that idea? Okay, next. Which sequence of transformations maps ABC onto DEF? That statement right there is so important because you have to know that this is where you're starting and this is where you are finishing. So a lot of times we think the thing in quadrant 1 is where we're starting. There's no primes on these to help us. We need to think about that. Okay. Let's do some analysis of their names. Okay, so ready? Dr. Teddy Roosevelt. Dr. Teddy Roosevelt. Do we need dilation?
No.
No. So now let's analyze orientation. So remember, that's what you're doing here. Analyzing orientation. Okay. So DEF, that's going counterclockwise, right? ABC, that's going counterclockwise. So it can't be a single reflection. Could it be 2 reflections? So could be 2 reflections, but not a single. Orientation is the same. They're both counterclockwise. All right, so let's look at, so then I start to look at things. Do you guys see how DF is kind of like pointing up? Is AC pointing down? Sure. Right? Could you turn your paper and kind of see something going on here? Does rotation feel kind of right? Okay, so now let's start to go through the 4 choices. The first one says, reflect over the x-axis followed by a reflection over the y-axis. Uh-oh, it's a double reflection. Is that one going to work? Let's just do point D and see if it works. Reflect over the x. Reflect over the y. Does it get, oh wait. Oh, what did I just do wrong? Did I start at finish? Yeah. Oh, bad girl. Right? I'll just do it this way. So wait, reflect. Oh, wait. Erase. It's not that big of a deal. We have to do this way first, right? X. So A goes up here, and then A goes over here. So does it work? Yes. Does C go up here, and then C goes to F? Uh-oh, did I already find my answer?
Yeah.
Yes.
That's a great thing.
That's a great thing, but I did do it backwards. Let's look at these other choices and see what's wrong here. B says a rotation of 180 degrees followed by a reflection. Wouldn't just this be enough? Would a 180 degrees around the origin work?
Yeah.
Yeah, it would. Ooh, a 90-degree rotation. So 90 degrees clockwise. Clockwise is this way, and a reflect over the y-axis. But a single reflection is going to mess with things, isn't it? Right? Last one, translation and rotation. if we translate 8 units up and 1 over and reflect, point A will work, but it's not going to work for the other points. Okay? So translation and reflection doesn't work. So then the last question at the bottom, and I rushed that, and maybe I need to change the order of these choices, is it says describe a single transformation that would map A, B, C onto D, E, F from above. Did we find one of those choices? A 180-degree rotation. Around the origin.
So that's also point reflection.
Yes.
That's what I read.
Yes.
So we also counted.
So the same thing is point reflection through the origin. And so point reflection does not change orientation. Did you just hear what I said? Point reflection does not change orientation. Only line reflection. Boo. Okay.